Welcome back to freehighschooleducation.com. Today we are going to do chapter 5.6 on page 190, equations with absolute value. Here we just remind you that the absolute value of a number is its distance from 0. So if we have here a number equals in absolute to 5, like if x is equals to 5, then x can be here or can be here. So we have two values for x. If x is 5, this comes out from the absolute as 5, or if x is minus 5, this comes out from the absolute as 5 also. So we use this principle now to solve equations with absolute value. We are going to do the example in the chapter, example number 1 on page 190. Absolute x minus 1 equals to 3. When we are solving these equations and at the end we should get something like this, this will be like our variable and we are isolating it. This amount, which is inside the absolute, should always equal to a positive number on the other side. If we get something like this, then this has no solution, because by definition, whatever is inside the absolute comes out as a positive number. So here, our solution will be a null set. Similarly, if this is equal to minus 3, this would be, the solution will also be a null set in this case. So at the end, we should get the absolute equal to a positive number. Now this amount inside the absolute can be equal to 3, or it can be equal to minus 3. So we have two possibilities, one or the other, and this is a typical example of a disjunction. So let's equate this to 3, and let's equate it to minus 3. And we solve both conditions and we see what we get. In the first situation, we move this to this side, so we get 1 plus 3, and that's 4. And the other situation, we get x equals 2, we move the minus 1 to the other side, and we get x equals to minus 2. So we have here two possibilities that fit this equation. X can be equal to 4, or x can be equal to minus 2. And we have always to check our results in the original equation. So let's check the result. If I put 4 instead of x, I get 4 minus 1, and that's equal to 3. If I put minus 2, you get minus 2 minus 1 equals to 3. And here there's a question mark. Minus 2 and minus 1, that's minus 3. It comes out from the absolute as 3, so this is also true. So these two solutions are acceptable solutions for this equation. Now let's do some of the classroom exercises on page 191. The first one is absolute x equals to 6. Here x can be equal to plus 6, or x can equal to minus 6. The second one, absolute y equals to minus 1. The answer here is a null set, because here we have a minus, and whatever is inside the absolute should come out as a positive number. So there is no solution for this equation. Number 3, absolute z equals to 0. And the answer, z is equals to 0. Number 4, absolute d plus 1 equals to 4. We take 1 to the other side, so absolute d equals to 4 minus 1, and absolute d equals to 3. So d itself equals to 3, or d equals to minus 3. And if we replace here, obviously we are going to get a 3 on the other side. Number 5, 2 absolute b equals to minus 8. We divide. It is obvious from the beginning that this has no solution, but we are going to divide everything by 2 to see absolute b, how much is going to be equal to, and it's equal to minus 4. And in this case, this is impossible, and there is no solution, and the b is an unset, or the solution is an unset in this case. Number 6, y minus 6, absolute y minus 6 equals to 10. Again, this amount inside can equal to plus 10 or minus 10. So our first equation is, and our second equation, so we have y minus 6 equals to 10, y minus 6 equals to minus 10. And we solve. Here in this case, y equals to 16, we take 6 to the other side. Here in this case, y equals to minus 4. Now we need to replace these values in the original equation. So this is 16 minus 6, and that's equal to 10. That's an acceptable value. And then we are going to do the second one, and that's minus 4 minus 6, and that gives us minus 10, comes out from the absolute as 10, and this is an acceptable value. Number 7, absolute 2y equals to 10. 2y equals to 10, or 2y equals to minus 10. And we divide everything by 2, and y equals to 5, or y equals to minus 5. If we replace y here with 5 or minus 5, we get a 10 when the amount comes out from the absolute. Finally, number 8. Absolute 4x minus 1 equals to 5. Here, this amount can equal to plus 5 or 4x equals to 5 plus 1, 4x equals to 6, and x equals to 3 over 2. In the other case, 4x equals to minus 5 plus 1, 4x equals to minus 4, and x equals to minus 1. Again, we replace these values in the original equation and check to see if we can get the right amount on the other side. So let's do the minus 1 first. Minus 4 minus 1, and that gives a 5. That's the correct value. And 4 times 3 over 2 minus 1, is it equal to 5? And here we cut 1, 2. We get 6 minus 1 inside the absolute. Is it equal to 5? And that's 5 equals to 5. And this is another correct value. So x has two values in this case, 1.5 and minus 1. And with this, we come to the end of this session. We hope to see you again.